Hello, I'm Atze van der Ploeg, and I'm also a lecturer on project application development. I'm also the lecturer for object-oriented and functional programming, which you'll be taking in period 1 of year 2. This course used to be called Advanced Programming for Computer Science. So this year we decided to give it a bit of a better name, a bit of a more descriptive name, hence that it's now called Object-Oriented and Functional Programming. But now I'm here to talk to you about the C programming language. So what is the C programming language? It's a fairly old programming language from 1972, developed by Dennis Ritchie at Bell Labs. And what they were trying to do, so at the time, it was still a fairly new concept that you could use a computer to run multiple programs, maybe in succession, and that you didn't need to physically do something to turn on the new to run the new program, or that you could handle multiple types of peripherals, maybe multiple printers, maybe a screen, this kind of thing. This was still a sort of a revolutionary concept at the time. So they were trying to develop a new and better operating system, and for this new and better, to program a new and better operating system, they needed a new and better language, a new and better programming language. So for this they developed C. And C was a successor to the programming language B, which in turn was a simplification of the programming language BCPL, Basic Computer Programming Language, something like that. So this whole project was sort of a successful endeavor. So Unix, the operating system that came out of this, is still widely used today, and derivatives of this like Linux and BSD are also quite common. And the C programming language is the most popular programming language in the world, at least according to some index, namely the TIOBA Programming Language Popularity Index, which is a fairly important and respected programming language popularity index. And it's number 1. The other languages in the top 10 are all much newer, so this is really a fairly old behemoth of a language. So it's typically used in sort of systems programming, so operating systems, maybe some embedded systems, this kind of thing. So what kind of famous programs have been written in C? So there's quite a lot of famous software that has been written in C. So currently all operating systems that are commonly used, the kernels of them have been programmed in C. So this holds for Windows, OS X, this is the Mac operating system, Linux, Unix, Android, which is based on Linux, iOS, which is based on BSD. All of them are programmed using C. Also, some of the old school first-person shooters have all been programmed in C. So Wolfenstein 3D, Doom, Quake 1, 2, 3, all of them have been programmed in C because speed was of the essence at the time, and at the time the only way to get to this was the programming language C. So nowadays video games are more commonly programmed in C++, especially sort of the AAA titles, Grand Theft Auto, this kind of stuff is programmed in C++. If you go more indie titles, they're typically programmed in C# because they're using Unity, which is the game engine. Anyway, so old school first-person shooters have all been programmed in C. Git, which is the most popular version control system, has also been programmed in C. So most Linux tools, ls, abk, set, all this kind of stuff, dir, this is a Windows thing. The Windows thing has also been programmed in C. So all of this has been programmed in C. It's also used quite a lot in embedded systems. So embedded systems meaning microwave sensors, all this sort of small electronic devices. So maybe some microphones, maybe these headphones, probably if they have some software, which I think they have, it's probably been programmed in C. And there's much more. So it is the most popular programming language in the world. So quite a lot has been programmed in C. It's really been quite a successful and influential language. So here's Hello World. Actually, this is a very old version of Hello World. I'm not sure this would run anymore, but I think this specific Hello World hangs on the wall at Bell Labs somewhere. And this has been signed by Brian Kernighan, which is also been a very influential person in the C programming language. So what is C compared to C++? Basically, C++ is a superset of C. So most of what you would type, all of what you would type in C is also valid C++. But you typically use it a bit more. So C is sort of a stripped down version of C++, right? So none of the fancy features. So meaning no classes, no generics, no references, only pointers. Much standard library, on operator overloadings, namespaces, streams, exception handling, no resource allocation is acquisition, none of all this stuff. No object-oriented programming, none of this stuff. It's really quite a simple and small language, especially compared to C++, which is a very, very big and gigantic, complicated language. So this is also the upside. C is much more easier, and is much in the sense that it's much easier to master because there's much less to master. So as I said, C++ is a superset of C, meaning that most C code compiles as C++ code. And C is notorious for memory errors. So there's no checking on any of these pointers. If you go past the end of an array, no one will complain, right? So it might be that you forgot you've got some buffer for, let's say, your networking stuff, and if you send some messages in some order, then it might be that buffer overflows. But there's no checking on this buffer, so it might happily overwrite some program code somewhere. So this is typically a source of errors and vulnerabilities. And Sebastian can tell you all about this. All right, let's look at a small example of a C program. So let's run this in an actual editor, so I can actually run something. Okay, so before looking at the program, let's compile it. So my program is called args.c, and there's also something called hello.c, which is what you just saw. So we can also run hello. Let's do that. So what does this mean? Compile hello.c and output the program and call the program hello. So when you're developing, you're probably going to be using a makefile, but here I'm doing something super simple. So I'm just running the compiler called GCC, which is the GNU compiler collection C compiler. You could also use Clang, but I'm not sure if I have it installed. No, that's a newer compiler. I'm using the old school compiler. Anyway, so what does hello do? We can run it. It says hello world. I forgot to put a -n at the end, so it's running the same. It's ending at the same line. Anyway, I'm now going to show you the other program, the other example, which is called args. And I'm outputting this also in args. So what does this program do? If I run it, it says, I want 2 command line arguments. So command line arguments are the things beyond here, right? So these are 2 command line arguments. Let's say John, and it says expected 2 command line arguments, but I only got 1. Okay, let's give it 2 command line arguments, John and Bravo. Then it says, hello John, you entered the code Bravo. Okay, how does this program work? So we start out by including the standard I/O, which is it's a library for standard I/O, meaning printing something and reading stuff from the terminal. All right, there's a main method. This is the entry point of the program, and it's returning an int, which is this int is the status code. So if it's 0, this means the program is successful, and if it's something else, then the program is not successful. The idea here is that you can use this from other programs to check if this went okay, if you use this in the script or something. So you can also see this from the command line. If I can ask for the status code, which is 0, meaning success. Now, if I do something like this, then the status code is 1, meaning not okay. So you can use this in your bash script to test if it's okay, if something went okay. You probably won't be needing it in this course. All right, so how does this program work? So this thing gets the command line arguments as arguments to the main function. So the first argument is the argument count, which is the number of arguments that has been given. And the second argument is actually the number of, is the actual arguments. So this means it's a pointer to a character, and the pointer to a character, you can think of this as sort of an array of characters, meaning a string. There's no string type in C like there is in C++. And then it's not just one pointer, it's a pointer to a pointer of characters. And you can think of this, and I'll explain to you more on this later, as an array of characters. And each array of characters is a string, so it's an array of strings. So these are the command line arguments. You don't know how many arguments there are from just this pointer to a number of strings, so that's why you need this extra argument here. All right, the name of the binary, in this case args, is always the first argument in this list. Then we check if we have less than 3 command line arguments, because the name of the binary is also always the first one. So if we need 2 command line arguments, you need 3 things in this list, as the name of the binary is the first one. Then we use this printf thing, which is different than the streaming output API you would use in C++. So in C++ you would use something like out expected blah blah, and then maybe something like this, end line. Maybe you would do something like this. All right. But we're not using this. We're using the C way, which is with a function called printf. So what does this do here? It says print this string, expected 2 command line arguments, but got. And this %d means plug in number here. So which number? This number. So this is the number of command line arguments we actually got. And this /n means end the line there. If we want to print more numbers, let's say, and another number, then we would do it like this. Oh. So if you add more numbers here, they will be plugged in there. So let's check this out. See now, so these numbers are plugged in as you would expect, like this. All right, so we didn't have enough command line arguments in this case, so we returned 1 for error. Otherwise, we get this you can think of as a character pointer, meaning a string. I'll talk to you more about this later. From the first argument, so this thing you can access as if it's an array. That's why you can think of it as an array. So the main difference being that you don't know where this thing ends, which you might also not. You also don't know with an array, at least not in C. So here's the name and here's the code, and then you can use printf. Instead of saying %d for a number, you can also use %s to enter a string. So this will print what you saw earlier. Then we return 0. Oh, return 0 for successful execution. All right. So after this example, let's discuss C briefly. So what are we going to cover? We're going to talk about arrays, pointers, memory management, strings, structs, and I/O. And I will be super brief about all of this. So basically, C shouldn't hold anything new for you. Because most of this stuff, or all of this stuff, has already been covered in computer programming. So if you feel you need more information or more refresher after this lecture, I will link a couple of good video lectures in the Canvas page. All right, let's start with constants. So constants are different in C than in C++. So if you want to define a constant, you say define minutes per hour as 60. So this actually means that this is actually text replace. So this means that in the code below, replace all occurrences of minutes per hour with 60. So we cannot use this normal C++ construct would be const int minutes per hour is 60 because this is simply not supported. All right, you can also make a type alias using typedef. So what you say is typedef existing type as new type. So for example, if you want to call the integer type, you want to use the name word t for this. So typically this is useful for this exercise because you're using words all the time. Then you would say the int type of length 32 I will now call a word. And most of these int types are defined in standard int.h, which you can include to use. All right, pointers. So you already got pointers in computer programming. So I will be basically this is a refresher. If you need more refresher, then there's a link in the Canvas page. So what is a pointer? It's a memory address that memory item that references an address. So for example, here's the address space, right? So this is your ROM basically, and these are the addresses in hex, so 100, 101, etc. And here is, let's say we have some character pointer, which is called my pointer. So this thing has some value and it's pointing to some other place in memory. So because the value here is 501, it's pointing to this particular address, to some character, and this character has the value 42 in hex. So this pointer is pointing to this address, and the next address it's pointing to is this one. So if you would type my pointer and then 1 instead of my pointer and then 0, so my pointer 0 will give you this thing, 42. My pointer and then 1 will give you whatever value is over here. All right. So the address, this is the address of operator. So the address of my pointer is 100. And the address of my car is 501. So if you say my pointer is the address of my car, then this will give you this setup. Now this is what is going on here. Right? Yeah. So my pointer now points to the address of my car. So you can think of a car pointer. So it's very similar to an array type. So you can also use the brackets. So yeah. So the type of this thing is a car pointer. This whole thing setup can be a bit confusing, but you can dereference using star. So star my pointer is 42. So this will give you the address, the value of the thing that's pointed at. This is the same as saying my pointer and then angular brackets 0. So arrays is a continuous list of elements of a certain type. There's many ways to define. For example, here you define an array of 1024 elements. Here's an array you initialize of length 3, which has elements 1, 2, and 3. Or, and this is equivalent, you can say it's an integer pointer. And then here I say, give me 1024 bytes, I guess. So the first element is at 0. As I said, the nth element is at n. And as I said, the my array 0, this thing here, is the same as star my array, and all of this is basically the same, right? So what you do is my array 42 is actually a bit confusing, but this is the same as 42 my array. And all of this is the same as my array plus 42. So this means my array, which is an int pointer, plus 42 means 42 integers after the first integer that's pointed at by my array, and then dereferencing it. So it's C, so there's no bounds checking whatsoever. So you can happily do my array plus a gazillion and end up somewhere which is completely outside my array. If you access some memory address which you are not allowed to access, you will get a segmentation fault, and then you have a bad night's sleep debugging that. Okay, types of memory management is the same as in C++. So there's static memory management, which is all the global variables. There's automatic memory management, which is the stack, right? So every time you declare a new variable, like an integer, then this is created once you enter the function and deallocated once you exit the function. And there's some manual memory management. You can manually allocate, deallocate stuff on the heap using malloc and free instead of new and delete, which you would typically use in C++. So how do you allocate this stuff? You allocate using malloc, and you can request malloc. This means give me some bit of memory, which will give you back a void pointer, which means some pointer to some memory address. And you can cast it to an integer pointer or some other type of pointer. But it basically says, give me some memory. It will allocate n bytes of continuous memory and return a pointer, which you should then cast to the type you actually want it to be. This bit of memory is valid. It can also, if there's no memory available, it will return null. This bit of memory is valid until you say free on this pointer you got. This will give this bit of memory back to the operating system. Alright, let's look at an example. Suppose I have an integer array. So this gives me an integer pointer, and I ask, give me a bit of memory which holds the size of an integer, which is, I think, depending on so there's the number of bytes that fits as an integer. Depending on your architecture, this might be 8 bytes for a 64-bit architecture. So this will give you 8 times 5 bytes, which is 40 bytes. And then so depending on your C version, you might need to cast in between here. This will give you an integer pointer, and this will work like this. On the stack, you will have some variable called myArray. This will point to some memory on the heap, and you can index this stuff like this. And after you're done with it, you say free myArray, and then this will give the memory back to the operating system. So, as I said, C++ has no string type. A string is an array of characters terminated by a special null character. This is also, in retrospect, a very poor choice. So a lot of bugs also come, and a lot of vulnerabilities come from this setup. So, for example, this is a string. If you say a character array with hello and then ended by a null character, this is a valid string. And this is exactly the same as this. Both these would end up with exactly the same setup. So as I said, the character array and the character pointer are basically the same thing. And you can use this character pointer, as I said, like an array. So you can also point this pointer, you can also let it point to somewhere else in the string. For example, you can ask for the address of the first element of my string. And now this myString2 will point to basically here, to the rest of this string. There's some built-in C standard library functions for this, like string duplication, string concatenation, etc. So you cannot use is to compare strings, because you will use it to compare pointers. So it might be that you have 2 bits of memory, both saying hello, and 2 pointers pointing to these 2 bits of memory. but these pointers are not the same, right? So maybe you're not exactly testing if they're pointing to exactly the same bit of memory, but you not really care about that if you're comparing strings. You want to know if they both say hello. So instead use strng, which is shorthand for string compare. A struct is a sort of a stripped down version of a class. So it's a class without the methods. So it's a composite data type. It's a record. It basically groups a bunch of stuff together. For example, you can put two integers into a point. Then you would have struct point, int x, int y. And this whole thing is a type. So typically you use it in combination with typedef to give this whole struct thing a name. And afterwards, if you declare some variable like this, struct tag name, and then the name of the variable, and afterwards you can say mystruct.member1 or mystruct.x. Or if you have a pointer to a struct, then you can use this notation, mystruct pointer to arrow member1 or arrow1 or arrow x. Sorry. So I already showed you some of the printf stuff in the example. So writing stuff, you can use printf, which will write something to standard output. You can also use fprintf, file printf, where the first argument is the file, or the file. So in this case, it's standard error. And you can also read the documentation on printf by googling monprintf or typing this in your command line. Ah, look at this. All kinds of information. All right. There's for reading, you can do getC, and then there's some file, in this case standard input. This will get you a character, or you can use fread, which gives some buffer. If you want to use this, I recommend you Google or monpage, ask the monpage of this. So this says, into this buffer, read one element of so many bytes, the size of a car, which is 1 byte, from standard input. And there's also scanf, which is similar to printf, but for reading stuff in. You can also use read files using fread and fwrite and fopen. For example, like here, if you have standard.io.h and some main function, then you can ask for a file pointer here, which you say open my file in read mode. Then you use this, you get this file pointer back. Then you declare some buffer and you read, let's say, 10 characters into this buffer. So afterwards, this buffer will hold the first 10 characters from my file.txt. So in the exercise, you might need to access a variable from another file. If you need to do this, you need to say extern. So suppose you have some file and it declares a variable called myCounter, and now you want to use this in another file. Then what you want to say is extern int myCounter. This says I'm using some external variable called myCounter. You can only use this to access non-static variables. There's also a switch statement, and what this thing is doing is the reverse Polish calculator from the example from Sebastian. So we're switching on some character, and then there's a number of cases. So suppose this character is plus, then we end up here. It goes, we pop something, we pop another thing, and we push A plus B, and then we break. If this break is not there, we would just continue down. And this example of the reverse Polish calculator is also made available to you. So for minus it's the same. It's a bit boring. If you multiply two things, you also pop two things. If you get an end of file, then you print the top of the stack, and you do the same thing if you encounter an end of line, except that then you don't exit. And by default, if none of the other cases apply, then you end up at the default case. And then in the default case, we just push the number on the stack. So this minus here, so 0 has some number, let's say 100, and 1, and we know that 1, the character 1, also has some number, and that it's 1 higher than the number of 0. So if you subtract the value of the character, if you say the character 1 minus the character 0, you get 1. Similar for the other numbers. Note that this does not work to push numbers that are more than 1 digit. Alright, that was it on the C programming language. I hope this this refresher was useful. And as I said, if you need more information on the C programming language, I put some useful links on the Canvas page. Alright, let's continue with code style.